Rather not.
The moment you've all been waiting for! We will now go to the Unit 6 practice test in preparation for the test tomorrow. This is 2 Biddy with my second period algebra class. Welcome to the show. Let's go. Anything to the 0 power is 1. This has a naked negative, so we know that the first thing we should do is put some clothes on it. That's right here, okay? So then we can think, well, wait a minute. To make a negative exponent positive, I have to put it under 1, so this needs to go in the denominator. But the negative 1 is going to stay in the numerator, so my answer is negative 1 over 2 squared, which is negative 1/4. A lot of you missed that problem, so you need to take the time to do the steps. Okay? The negative's not in the parentheses, therefore it is not impacted by this exponent. Yes, Lauren?
We put the negative out, not the 1.
That's fine, but if you put 1 over negative 4, you should really simplify and either put the negative here or there.
I put it in the middle.
That's fine. Middle's fine. Middle or above, just not in the bottom. Okay, 3. How do I make a negative exponent positive? Put it under 1. So I do that first. Unbelievably, some of you missed this one also. And then we get 1/9. Some of you put 9. You pretended, I guess, that the negative 2 was a positive 2 on the exponent? I guess. It's the only thing I can think of. Okay, number 4, to make a negative exponent positive, if it's in the denominator, it needs to go to the numerator. So that'd be the 8 to the 5th over 1, or just 8 to the 5th. Okay? That's what I call a gimme. Hope you all got that. Number 6, or 5, I mean. In order to make that negative exponent positive, it needs to go to the numerator. So I'm going to have 3a to the 9th over b. Nothing else moves. Only the negative exponent. Number 6. What is the value of this for y equals negative 1? So first thing I'm going to do is simplify the expression by getting rid of my negative exponents. So I'm going to move this guy down. So I'm going to have 4y cubed over x cubed. This is going to make it a lot easier when I plug and chug. So I'm going to have 4 times negative 1 cubed over 3 cubed, which is 4 times negative 1 over 27, which is negative 4/27. Really not that bad if you just take the steps to simplify. Okay, well then you get half wrong if you got positive 4/27. That's the only way you'd even get partial credit on that. So make sure you get that. Scientific notation, just a number between 1 and 10. I make this smaller by 6 places, so I need to multiply it by 10 to the 6, so it's still the same quantity.
I got that right.
Okay? Now this is less than 1, so I need to make this number between 1 and 10. So I actually made it bigger by 2 places, but I want to make sure that it's still equivalent, so I make it to the negative 2. You can always check this by multiplying it back out, because going from scientific to standard, the exponent tells you which direction to go. Negative is always left, and you would get back to where you started if you checked it. Okay, so this is the right answer. Number 9, standard notation. This is just going to be 5, and then the decimal's there, so I'm going to go 1, 2, 3, 4 places. Commas do help so you can know what the number is. 50,000 versus 5 or 500. Okay? Now this one, again, scientific to standard is the easy one. Move it 3 to the left, fill in those spaces with zeros, and I get 0, 0, 1, 2, 6. When I multiply things to the same base, I add exponents. That's a 1 there, if you want to think of that. So 2 times 1 is 2. And then g to the 2 plus 5, so it'll be 2 times 1 times g to the 2 plus 5 is g to the 7. Because when we multiply things with the same base, we add exponents. Another thing to do here is you could do the same thing. You could put all the numbers first so you don't make a mistake thinking you're going to move numbers because they don't have exponents on them. And then I have x to the 3 plus a negative 8. Because when I multiply things with the same base, I add exponents. And then I have y to the negative 2 plus 5. Negative 2 plus 5. So now I get negative 4 times 2 is negative 8 times 5 is negative 40. So I'm going to have negative 40, x to the negative 5, y to the 3rd when I add here and here. And then the only thing that's going to move is that negative to make it positive, so it's going to be in the denominator. Again, just take it step by step, pretty simple. Okay? So score the front page. There are 30 problems, so if you miss one, take off 3.3%. For each one, pretty much, each one's worth 3.3%. Number 13, when I multiply in scientific notation, I multiply the numbers. And when I multiply powers of 10, I add exponents. 2 plus 5 is 7. But that's not in scientific notation. I know at least one person didn't get that right. To make this in scientific notation, I need to make it smaller by one place. So I need to make this bigger by one place so that it's still the same value. Number 14, now it's a division problem. So I have 9 times 10 to the 5th divided by 6 times 10 to the negative 7. I divide the numbers. 9 divided by 6 is 1.5. And then 10 to the 5 minus a negative 7 is 12. 5 minus a negative 7 is plus a positive 12. Okay. Number 15. Last year, a large trucking company delivered this many tons of goods. The average value was that much per ton. So how am I going to find the total value? Multiply 9 times 10 to the 5th. Now, since we're working in scientific notation, to me it makes sense to just make that into scientific notation, since I have to put my answer in scientific notation. Okay? So I just write it in scientific notation. 9 times 1.7 is 15.3 times 10 to the 9th. But that's still not in scientific notation. I need to make it smaller by 10. So then I need to make this bigger by 10. And that's the answer. Sure. And just so you know, I mean, if you want to get an idea about this, just to see how much this really is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're talking about $15,300,000,000. Okay, number 16. When I have a power to a power, I multiply the powers. You could also think of this as p to the 6 times p to the 6, and you could add those exponents and get it that way too. Okay, here the negative 9 will only impact the m squared because the parentheses, and will not impact the m to the 7th. So I first need to simplify PEMDAS, right? Parentheses, exponents, then I multiply or divide, then add, subtract. So if I do exponents, I get m to the 7th times m to the negative 18th. When I go ahead and simplify this, and then when I multiply these, I add exponents. 7 plus negative 18 is negative 11. And then I know I can't have negative exponents, so I need to put it under 1. That's the answer. Okay, if you put that, you get half. This one, the only thing I see students forget is to distribute the power times both. So 3 to the 4th, h to the 12th. 3 to the 4th is 81. Okay, so if it's small like that, go ahead and multiply it out. Number 19, we have, we need to distribute this 2 again. So 2, 2, 2. So I'm going to get 3 squared, x squared, y to the 6, x to the 6, y to the 6, times x to the 6, y to the 6. Sorry, that's the 6. I don't know what happened there. I'm going to erase that. X to the 6, y to the 6. So now I can add things that are like bases, add the exponents of like bases. So 3 squared is 9, x to the 2 plus 6 is 8, y to the 6 plus 6 is 12. Okay? You got to do that one step by step. Don't try to do too much at once. 20. Divide things at the same base, you subtract exponents. That's a gimme. Make sure you get those ones right. Same dealio here. It's always the top minus the bottom, and you're going to get negative 16. And then how do I make a negative exponent positive? Put it under 1. Good. Okay. 22. So, again, notice I'm going to go g to the negative 4 minus a negative 1, h to the 11 minus 3. Then I can do this plus a positive and realize that it's g to the negative 3rd, h to the 8th. And then I need to make that positive by putting it under in the denominator or down below. Okay? And that's what I get. Okay, number 23, massive black hole. How many times more massive than the sun would a black hole be? So what's biggest?
The black hole.
Black hole. Okay, that's where reading plays into math. and then we get this, and then we get there, we get 3.7, obviously, right? So we know you have to do the math. Only thing we had to do here, and I wrote 6, not 30. 36 minus 6, 36 minus 30 is 6. So the answer is D.
Just for answering, just for like B, like.
Yeah, that's fine. On the few multiple choice, that's A-okay. Okay, what is the simplified form of this? So it's b squared over 7 to the negative 2, which would be, to make that positive, I need to put it up top, b squared times 7 squared, or 49b squared. You just had to move it. I know it looked funky. I couldn't change the formatting to get what I wanted, so I just had to do it like that. Okay, what is the graph of this function? So if my domain is 0, 1, 2, 3, 4, and my y-axis goes up to 300, use intervals of 300, so 300, 600, 900, 1200, 1500, 1800, okay? So what is it going to be at, if I do a table here, what is it going to be at 0? 5 to 0 is 1 times 3 is 3. Make sure you follow order box. Okay, what is it going to be if it's 1? 15. What's it going to be at 2? Good. Okay, what's it going to be at 3? Okay, that's 120. Yep, 375. What's it going to be at 4? 1,000. Okay, so the main idea is that you see that it is gradually getting bigger or smaller. So if I go 0, 3, I mean that's barely there. That's probably way too high. 115 obviously has to be a little higher. 275, it's still, these are way off, right? I mean, if we really want to get this right, I mean, this would just be way, this would be even lower.
375.
Yeah, it's fine. It's that's what's hard about exponential functions is they get so big so fast, right? That, you know, it's hard to get an appropriate scale. Because, so then if we go to 3 and 375, now we're talking a little bit. And then if we go to 4 up here, so you're going to get the general idea that it's going to go like this. So just, we want to make sure you understand that that's what it's going to look like. You have a question, Pia? How, yeah.
It said,
Provide your table of values to the right of the graph. That's your work. Okay? I think what I'm going to do is I'm going to make just the first coordinate graph.
yeah.
Although, yeah.
No, I wouldn't make
I tried to take just the top half of it, the first and second quadrant, but what? It's okay. This one I changed to 0 through 14. So 0, 2, 4, 6, 8, 10, 12, 14. And this one intervals of 0.2.
How did you fit 16?
Okay. And then when I plug in, well, this is a good time to use the graphing calculator. Y equals 9 divided by 10. 9 divided by 10 to the x power. This is what I did. And then I'm going to get my values. Okay? So James is going to read those to me. What am I going to get at 0?
1.
Okay, at 0, I'm going to get 1. Good. Okay, that's why 1's on here. What am I going to get at 1, James?
0.9.
What am I going to get at 2?
0.81.
3?
0.729.
0.729, okay. Kind of looking linear. That's what I don't like about this one. It's kind of hard.
Yeah, that's what
Go ahead. Continue.
0.6561.
Is 4. Okay. 0.6561. Okay.
0.59049.
What's 6? Let's just do every other one. What's 6?
Okay, 0.53144.
Okay. What's 7?
Second.
Or 8. Sorry. 8.
0.43047.
Okay. 9. 10.
34868.
12.
.28243.
and 14.
.22877.
Okay. So obviously some of these are off by a little bit, but you can get the general idea that it's going to be like this. It'll approach 0, it'll never get there. Nope. Because you're always multiplying by a fraction. It's going to get extremely close, but it can never get there. It's weird, but that's just the way it is. You'll come across lots of functions like that as you get into higher math. Okay, 27. Is this a growth or a decay problem? Thank you, James. It is a growth problem, okay? So the amount is 1,500, and it's going 2% a year. So after 1 year, it's going to be that much. But how long are you doing this? For 4 years. So what do you get?
162.
When you put that in your calculator, you get what?
1623.65.
1623.65 or whatever you said. So that's going to round up to 1,624 a year. Okay. All right, 28. Same dealio. It's similar to the last problem, except we're going to use principal times 1 plus, and this is compounded annually, so I get to divide by 1. This is the easy one. So it's the rate is a decimal divided by n, or the how many times it's compounded yearly, and then you're going to multiply the n times the number of years, or t. So you're going to have 2,100 times 1.04 to the 4th, and when you do that in your calculator, you get clear 2,100 times 1.04 to the 4th, and you get 2,456.70. I know.
I did it.
Good job. Okay, 29. Same one as the last one, but this one, it's monthly, so there's a difference. So make sure you know how to apply the difference there. It'd be 1,400 times 1 plus 0.07 divided by 12, because it's monthly, there's 12 months in a year. And then you're going to multiply n, also, so that's twice in your equation, and then times the number of years. So when I simplify 0.07 divided by 12, I get 1.00583 repeating, right? 264. Okay. Now, this is a good one to explore on the graphing calculator. So,
You can't round off the
I know, check this out. Well, here's what happens. This is a really good discussion. Unfortunately, you're not going to be able to see it on the video. So I'm going to stop it right now. No, I'll just explain it. You'll just have to listen. Okay, so we are going to plug into our formula the problem, which is 1,400 times 1.00583, that's without continuing the 3, to the 264, is that right?
Yeah.
Okay, and I get 6495.59, which is really close to B. Okay, but look at what happens. Since that's a repeating decimal, watch what happens when I put in some extra 3's in there. Okay, that's telling the calculator that it's repeating, so the calculator is going to treat it like that. Okay, and then watch what happens. I get the exact right answer. So if you put in I don't know how many you need to do, you can experiment with that, but a graphing calculator is smart enough to know that when you start repeating a number like that, it's saying, oh, wait a minute, that must be repeating. And then you're going to get the exact answer. But that's why it's multiple choice. Okay, so the answer on that one was B. Number 30, this is one where I think a few of you are still not there. The decay formula, what do we write for the beginning? What letter? What does it say in your notes? B? A? Alright, I'm going to look at what mine says. Mine says Y. Y equals A times B to the X. Okay? So if it's decaying, I need to multiply by what it's going to be after, what it is after the 12% off. So if something costs $83.50, and this is a true problem, boats, cars typically don't go up in value, they go down, unless it's a classic car. Houses go up. So this depreciates or decreases, and houses appreciate typically. Okay? Because houses, everybody needs houses, and so oftentimes you update houses, and there's the land, and it kind of goes with the rate of. I'm thinking of the word, I can't think of it.
Hi.
Hi.
I'm just gonna leave this with you.
The rate of inflation, that's the word I was looking for. So when inflation goes up, usually housing costs or the cost of housing goes up. But cars, as they get higher miles, they need to go to the shop more, and they aren't worth as much, unless it's a classic. Anywho, so how much is this going to be worth after 1 year? Well, how do I find out the value after 12% off? It's 88% of its original value. How do I get 88? 100 minus 12. Okay? So it's going to be worth 88%, okay, after it decreases in value by 12%.
Wait, I don't think you got 88.
What's 100 minus 12?
88, how do you get those numbers?
100 minus, it's in the problem. 12 is in the problem.
Oh, okay. I got it now. I was just confused.
Okay? How much will it be worth after 5 years? Okay? So we're going to just multiply it by 0.885 times. That's all we're doing. So let's go to the graphing calculator. So we have 8350 times 0.88 to the 5th power, and I get 4406.56. 4406.56.
You should make all these multiple points.
No. You need to show that you can do it. Okay. So here's a good application. You guys are gonna probably be shopping on spring break. Some of you. Hey, you go to Buck. Jeans are 25% off. Irregular $80. What percent of the total price will you be paying? Okay, this is a sidebar. If you have $80 jeans, okay, at 25% off, what percent of the total price will you be paying? What percent of the total price will you be paying? 75%. Okay? So look what happens when I multiply 80 times 0.75. I get the sale price. So this is really cool. I've been in stores and people are like, yeah, it's 33% off today. And I go, oh, it'd be $26.50. And they go, how'd you know that? So like it's math. But I also know that if I take the percent off from 100, I'm multiplying by whatever that leftover is, because I'm paying that percent of the total cost. So instead of having to find 25% and subtract it like you probably did in 6th and 7th grade, now you can instead just do it in one step. In your head, you can subtract that from 100, get this, and then multiply. Pretty cool, huh?
Why couldn't they just make $20 off instead?
Because what if it was $120?
But it's all the same jeans.
No, I mean, but what if all jeans are on sale in the store? They're not only going to be $80. Well, it could be. Sometimes you go into the Gap or something, it is $20 off all jeans, but because they're probably mostly priced the same at Buckle, I bet there's a wide variety. Try 50 to 150. Try 200 if you buy True Religion or something. Okay, and the bonus. I don't know if anybody got this right, but let's.
Oh, that was a bonus?
Yeah. Okay, so it's 2 cubed. I'm just going to do one step at a time. A to the 15th, b to the 15th, times 3 cubed, a to the 15th, b to the 9th, over 4 cubed, k to the 12th. So it's a complex fraction. 7 cubed, c to the 9th. Okay? Now I'm going to do some simplifying. This is 8. This is 27. 8 times 27. 216. 216. A to the 15 plus 15 is 30. B to the 9, 15 plus 9 is 24. Okay, so I'm just simplifying the top. Simplify the bottom. This is 64k to the 12th. Over 7 cubed is not coming to me at the moment. 343, c to the 9th. How do I simplify a complex fraction? I multiply the numerator by the reciprocal of the denominator, right? Copy dot flip. So it's going to be 216 a to the 30th b to the 24th over 1 times 343 c to the 9th over 64k to the 12th, which gives us 216 times 343.
74,088.
Hey, thank you. 74,000. Oh, but at this juncture, I know these have something in common. So what can I divide out of both?
Can you just do it the regular way?
I'm pretty sure no one's gonna get that right if bonus looks like that tomorrow.
That's not a very good attitude. But I mean,
I got to the
Oh, I got that
tiny
answer.
mistake.
I got that one.
well, good thing it's a bonus,
I
right?
didn't know.
74088. But Lauren, I would like you to work on cross-reducing because it's going to be really important moving forward.
Mr. Mama, what if I got that with 316A to 30th b to the 24th over 64k to the 12th over that one? But I didn't.
Yeah, it's a bonus. You got to simplify. Now, so when I divide those, just to see if it comes out nice and even, it does not. But I know they're both even, so I can do it. See, it would have been easier before, but that's okay. I think they're both divisible by 8. 74088 divided by 8, 9261.
I only missed 2 on this one.
Okay, over 8, and then everything else is the same.
Could you mark stuff we just simplified for that?
If you had this, I'd give you a half.
You wouldn't give us half if we had that though?
No, if you had this, you didn't know what to do with that complex fraction. You always have to simplify complex fraction.
Okay, but
We've been working on that quite a bit.
if
So, what, Lauren?
we got the 74088
Yes, I give you half.
half,
Uh-huh.
so we all got worked up in real life.
Right, but you need to understand how to reduce fractions. Now, if you would have divided out the 8 here, Lauren, it would have been a lot easier.
Did you get them?
What's it again?
I don't know how to cross multiply.
Cross-reduce, it's just dividing out the common factor. It's just like you reduce a fraction. I know you keep saying that, but if you want to get it, you got to say that. Okay, well, so you don't know how you forgot. Okay, so that concludes it. So, how many of you missed 1? Do you have a 97% on the practice test? Or on the test tomorrow? That's what you missed. How many of you missed 2? You'd have a 93. How many of you missed 3? You'd have a 90.
How many would you miss?
If you missed 6, 6 would be an 80. So below 6, if you miss more than 6, that'll be in the C's, D's, and F's. Hopefully none of you missed too many more than that. All right, make sure you watch this tonight. If you need to go over it slowly.